This video is a third sample problem for BOD calculation. Now, we are given with the following statement as the BOD5 of the raw Clarksville wastewater is 225 milligrams per liter. A long-term BOD test has revealed that this wastewater also has an ultimate carbonaceous BOD at 325 milligrams per liter. Now, the plant effluent testing has shown the BOD5 drops by 92% across the plant. Long-term tests on the effluent also show that the BOD decay coefficient is half the original value in the raw wastewater. Now, let's enumerate the given parameters, but before doing it, we are asked to solve for letter A, what is the BOD decay coefficient of the raw wastewater? On the other hand, for letter B, what is the ultimate carbonaceous BOD of the effluent wastewater? Okay, we are given with the following parameters. BOD5 is equal to 225 milligrams per liter. And the ultimate BOD for the effluent, this is equal to BOD at 3 to 5 milligrams per liter. And our time here is 5 days. Why is it 5 days? Because we are already given with BOD 5, or this is the amounts of BOD for the first 5 days of the water sample. Okay, so we're going to use time is equal to 5 days. Now let's proceed with our solution. For letter A, we're going to use this formula as BOD5 is equal to ultimate BODL times 1 minus epsilon raised to negative KT. Now plugging in the values, this is for BOD5, this is 225 milligrams per liter is equal to our ultimate BOD 325 milligrams per liter times the following quantity 1 minus epsilon raised to negative K. This is our deoxygenation rate constant times 5 days. Now this gives us the following values. Okay, divide both sides of equation with 325 milligrams per liter. So this is 2 to 5 all over 325 is equal to 1 minus epsilon raised to negative K times 5 days. If we're going to transpose 1 to the other side of equation, this becomes 2 to 5 all over 3 to 5 minus 1 is equal to negative epsilon raised to negative K times 5 days, or further eliminating the epsilon here, this gives us the natural logarithm of negative. Okay, let's eliminate the negative sign here. So this becomes negative 1 times the quantity of 2 to 5 all over 3 to 5 minus 1. Okay, and then eliminate the epsilon here. So we need to get the natural logarithm of both sides of equation. This in this form, this becomes natural logarithm of negative 2 to 5 all over 3 to 5 minus 1 is equal to negative k times 5 days. Now, further simplifying the whole equation, dividing both sides of equation with negative 5 days, our k now is in terms of this value, 0.236 per day. Now, for letter B, to solve for the ultimate carbonaceous BOD of the effluent, we are given with the following statement on this problem. We have the plant effluent testing has shown that the BOD drops by 92%. Okay? And long-term tests on the effluent also show that the BOD decay coefficient, or our K from letter A, is half of the original value. Now for letter B, KB, since we are given with half the original value from letter A, so we're going to get the 50% value of K from letter A. So this becomes KB is equal to 50% or 0.5 times 0.236 per day, or this is equal to 0.118 per day. On the other hand, since I'm going to read this again, plant effluent testing has shown that BOD drops by 92%. Okay. Now we need to get the BOD 5 remaining. So since it has dropped to 92%, how many has remained. So this is 100% minus 92%, or in terms of decimal, this is 1 minus 0.92 of the BOD from letter A, which is 2 to 5 milligrams per liter. Okay, so 1 minus 0.92, or this is equal to 0.08 times 2 to 5 milligrams per liter, or our BOD5 remaining for this problem for letter B is at 18 milligrams per liter. Now, we're going to use this formula. L is equal to BOD5 all over 1 minus epsilon raised to negative KT. Plugging in the values gives us L is equal to 18 milligrams per liter. Okay, this is the amount remaining all over 1 minus epsilon raised to negative our K, which is half from letter A. So this one, negative 0.118 per day times 5 days. Okay, the unit day cancels out, gives us our final answer for this problem for letter B. The ultimate BOD of the effluent wastewater is at 40.388 milligrams per liter.